All right, this video is for DMR number 2, H. Our first skill is finding the missing angle in a triangle. And as a reminder from DMR number 1, the sum of all three angles, when you add up all three angles will need to equal 180 degrees for all triangles, no matter what the triangle looks like. So in this first triangle, we have a 61 and a 61. What that's going to mean, since these two angles are the same, it would also mean these two lines are the same. And even though it's not asking us this, just as a review, when you have a triangle with two equal sides, it is called an isosceles triangle. Okay, so we are going to first add up 61 and 61. Or you could do 61 times 2. That would work as well. And that is going to give you 122. Next thing I'm going to do is I'm going to take my 180 and subtract my 122. Careful when you do this that you don't make any silly mistakes with your subtracting. And I end up with 58. So my missing angle right here is 58. All right, with number 2, we have a right triangle. It has this 90 degrees here. And we talked about in DMR number 1 doing a shortcut. So we only had to do one step because 90 and 90 equal 180. And if we already have 190, that means these two must add up to also be 90. So we could just do 90 minus 45, which is 45. So that means this angle right here is 45. 45 plus 90 would equal our 180. So again, just a shortcut that you can use when you have a right triangle. Now we're going to look at our rational and irrational numbers down here. And number 3, I hope you noticed in number 3, one thing that all of these numbers have in common is that they all have a fraction in some form or another. Now this is a proper fraction. This is a negative improper fraction. This is a mixed number. Here's another improper fraction. Here's a negative mixed number. But again, all of them have in common that they have a fraction of some sort. So rational numbers, if we're talking about rational numbers, all fractions are rational. That means every single one of these fractions, no matter what form it's in, would be considered a rational number. Looking over here at number 4, circle the rational numbers. I see all of these are decimals. Now, with decimals, we can't say all decimals, unfortunately, but we can say terminating decimals. Terminating decimals, I would be writing this on your paper if I were you. Remember, you get to use your paper on the quiz. So terminating decimals are decimals that stop, okay? They don't have the dot, dot, dot. They don't have a bar over any of them. So looking for some terminating decimals, this one stops. This one stops. I know it's negative, but it doesn't matter. And this one right here stops, okay? And the other type of decimal number that could be rational are repeating decimals. Repeating decimals. So these other two decimals that I haven't circled yet, I'm going to look to see, do they repeat? 0.6278. I don't know what's going to come after that 8. So that's irrational. And this last one, 0.7214. I have no idea what's coming after that 4. So irrational. So in this number 4, the terminating decimals were our rational numbers.